What if I told you that one single day on the calendar is the key to modern computing, big data, and even a puzzle that went unsolved for 100 years? Well, today, we're diving into that exact day. April 21st. It might look like just another box on the calendar, but in the world of mathematics, oh, it is a golden one. The big question is, why? Because on this one day, across totally different centuries, four incredible minds had breakthroughs that literally shaped the world we live in today. Let's meet them. Okay, our first story kicks off with a puzzle that stumped the absolute greatest thinkers for over a century. I mean, can you imagine a brain teaser so tough it takes more than 100 years and a supercomputer to finally crack it? Well, it was a famous problem about coloring maps, and the story of its solution starts right here with our first mathematician. Let's talk about Alfred Kempe, who passed away on this very day, April 21st, back in 1922. So Kempe went after this legendary thing called the Four Color Theorem. The question sounds simple, right? Can you color any map with just four colors so that no two bordering countries are the same color? He published a proof in 1879, and everyone celebrated for a decade, until a tiny mistake was found. But here's the amazing part. Even though his proof was technically wrong, his idea, his approach, was so brilliant that it became the foundation for the final, correct proof almost a century later. And get this, that final proof actually needed a computer to finish the job. Kempe's story is incredible. It shows us that sometimes in the search for answers, even a mistake can be a giant leap forward. So that's our first point on the April 21st timeline. Now, let's jump forward in time a bit and meet our next game changer. Now, let's get into an idea that is, and I mean this literally, powering the device you are watching this on right now. I mean, think about it for a second. Every single piece of digital tech we have, from supercomputers down to your smartwatch, it all runs on one single fundamental idea. What is that idea? Well, the principle behind all of it can be traced right back to April 21st, 1954, and to the mind of a man named Emil Post. You see, way before we had physical computers, Post dreamed up a machine that existed only in his mind. It wasn't made of metal or wires. It was a pure concept. This imaginary machine could solve pretty much any problem just by following a simple list of instructions, one step at a time. Sound familiar? That is the very definition of an algorithm, the basic building block of every single computer program we use today. Post's incredible work just reminds us that sometimes the most revolutionary technologies, the ones that change everything, spring from the simplest, most elegant ideas. So now we have two brilliant minds, both connected by the day they passed away. But you know, April 21st isn't just a day of endings. It's also a day of beginnings. Let's travel back in time for a bit to celebrate a birth. Our third story is about tackling a problem so deep, so profound, it was actually called a dream. You know, when a mathematical legend calls a problem their dearest dream, you know it's got to be one of the big ones. So who could possibly solve something like that? Meet Teiji Takagi, born on April 21st, 1875. He was the one who made that dream a reality. Takagi was a pioneer in a really complex field called class field theory. Now, the best way to think about it is like this. Imagine he created a grand map, or maybe a universal dictionary, for all the different types of numbers. He showed that these different number families, like prime numbers and integers, weren't just isolated islands. No, he discovered these hidden bridges connecting them all, revealing this beautiful, unified structure that nobody had ever seen before. And this map was so powerful, it actually solved that dearest dream problem, one that had left other mathematicians totally stumped for generations. What he really showed us is that the job of a mathematician is kind of like being a composer. You're listening for the hidden music, the secret harmony that connects the entire universe of numbers. All right, our April 21st timeline is really starting to fill up. Now, let's add our fourth and final mathematician to this extraordinary day. And this last story connects directly to our world of big data, of artificial intelligence, and how we even begin to make sense of these massive floods of information. I mean, we are living in an age of data. Every single second, billions of little data points are being created. So how do these huge companies and AI systems handle this constant flood of information without just shutting down? Well, a really important piece of that answer lies with a man born on April 21st, 1931, Robert C. Thompson. Thompson was a master of something called matrix theory, which is basically the math behind those giant spreadsheets that run our entire digital world. He was fascinated by the relationship between a huge block of data, the whole matrix, and its smaller component parts. And he figured out that by understanding the little pieces, you could actually predict the behavior of the whole massive system. It's kind of like learning the secrets of an entire forest just by studying a single tree. That idea is absolutely fundamental to how we analyze big data today. And this is his really powerful takeaway. To solve the biggest, most overwhelming problems, sometimes the best thing to do is to look for the answers hidden inside the smallest pieces. So there you have it. 4 mathematicians, 4 incredible breakthroughs, all linked to a single day on the calendar. So what's the common thread here? What connects them all? When you look at the full timeline, the connection is, well, it's undeniable. Kempe, Post, Takagi, and Thompson. They were all from different times, different places, but they were all fundamentally pattern finders. One saw patterns and colors on a map, another saw them in the logical steps of a machine, a third heard the hidden music connecting numbers, and the last found the secrets of a whole system in its tiny parts. They were all on the same quest, to find simple, elegant order in a world that looks chaotic. Because they were obsessed with that one question, what is the hidden pattern? We now have the foundations for computer science, for data analysis, and for modern number theory. Their legacy is all around us. Which leaves us with one final inspiring thought. What crucial patterns are hiding in plain sight today, just waiting for the next